Hey guys, welcome to Code Decode. In this video, we are going to look into some very frequently asked Java interview questions for 8+ years experience. Below, I have jotted down the technologies which are very commonly asked and is expected at 8+ years of experience, which is you should have a good hands-on experience with Spring Boot, Microservices, Docker, Kubernetes, CI/CD, Spring Security, Kafka, REST APIs, ORM framework, be it any Hibernate JPA, doesn't matter. Any cloud framework which you have worked upon, SQL or NoSQL, deciding between which and when to use is very important. Alerting systems and logging systems. So let's get started, and we are going to cover all these topics today in this video. So let's get quickly started. So when it comes to this Spring Boot application, when you say that yes, for 8 years of experience, you have worked on Spring Boot applications, the first thing they would ask you that if the application is on production, how would you monitor that application on production? So we have multiple tools and techniques out in the market which will be helpful for us to manage and maintain our application on production. And these are very important tools because if they won't be there, we will not be able to alert ourselves, we will not be able to observe our application on production, and our client might get hampered if the production app crashes or anything goes down by any causes. So the first important thing that you should always implement for the production ready application in Spring Boot app is actuator endpoints. So Spring Boot actuator exposes various environments to provide you the information about your production ready application, that is about its health, its matrices, the environment, and many more. The key endpoints are including these. The video for the implementation of actuator is already on the channel. Just let us know. We'll provide the link for that. The second is we should always have the APM, that is Application Performance Monitoring Tools. For example, Prometheus and Grafana. Always when you have a production ready application, just by deploying to production is not the task done. What you have to do is you have to continuously monitor your application that is up and running for your clients. Because even small downtime will cause you a lot of loss in the customer satisfaction. So better to keep your application up to date with the performance monitoring tools like Prometheus and Grafana. So what is Prometheus and Grafana? These are the two tools who work simultaneously hand in hand to provide you the proper data, matrices, and visualization of these data through dashboards. So Prometheus is the one who collects the data for your endpoints or the APIs, and Grafana is the one who queries the Prometheus, asks for these data, and show it on the dashboards in the terms of graphs and all, so that it is easy to visualize. Also, you can put alerting in Prometheus and Grafana. As soon as you have some downtime at your production app, you will get notified through Microsoft Teams, through emails, through chats, through Slack, and those hooks are always there where you can get notified that something is going wrong on your production ready application. Also, we have multiple more application performance monitoring tools like New Relic, Dynamo Trace, Datadog, and App Dynamics. These tools offer real-time monitoring, detailed performance, and alerting capabilities also. Nowadays, you can see a boom with the implementation of New Relic. Nowadays, it is on boom because it provides a real-time monitoring, detailed proper matrices, proper tracing, and also gives you a proper ability to provide the Git hooks for GitHub, for Slack, for Teams, all those things, all the alerting capabilities. The third important thing you have to do for your production ready application is you have to put proper log, and you have to properly aggregate and structure those logs. So you have to use tools like ELK Stack, that is Elasticsearch, Logstash, and Kibana for properly aggregating your logs across your application. And you should properly implement the structural logging to make the log search easier so that you can analyze and see where actually your problem is lying in your production ready application. Next, you should have a proper distributed tracing. So nowadays in the world with full of microservices, multiple microservices, any of the application might go down. So which microservice is down, where the actual issue is, for that you have to have a proper Jenkins and Sleuth implementation for proper distributed tracing with microservices implementation. So implementing a distributed tracing to trace a request as they propagate through different microservices provides a complicated situation to handle. So for that, you have to identify the bottlenecks and latency issues and where the request has actually gone wrong. For that, implement the Zipkins. And Sleuth basically added the trace ID and span IDs. So for one particular request, your trace ID remains common, but your span ID changes. so that you can automatically log in, see where actually which particular request at which particular microservices has went wrong. So that is why implementation of sleuth in Zipkins is very important for distributed tracing. The last one, as I always focus upon, is alerting. So if it is Sunday and your production application has crashed, how will you be notified that your clients are facing problem? Analyzing that will be a difficult task on the day where you have very less workforce. So for that reason, alerts are very important. So when you see that, okay, my production ready application has continuously getting 500 internal server error, or 401 authorization error, or 403 forbidden exceptions. So your Okta went wrong, your application went wrong. What has went wrong? For that, you have to have one person always ready to support your application which is on production. So for that, you need to have the alerts, so that manager and everybody is alerted that yes, something is going wrong and we need one of the engineer to look into it. For that, we have Prometheus Alert Manager. We have also multiple ways, like what I told you is that nowadays we have New Relic also. Even that has a very good alerting situations with integration with your Teams, your calls, your Slack, multiple ways. So setting up rules in these particular application management tools is very important, so that they can send you notification via email, Slack, PagerDuty, Teams, etc. The next important subtopic is microservices interview questions. So for this, whenever we implement multiple microservices, then we have a very important concept and picture, that is what is service discovery. So the interviewer might first ask you what is service discovery and did you use it. So when there is a large number of microservices in place, then you always need to have a service discovery, because if suppose I'll give you an example. Currently I have 3 microservices. Microservice 1 is on port number 9090, it's on 1991, it's on 1992, and some XYZ URLs. Now suppose, for example, Microservice 1 internally calls Microservice 2, Microservice 2 internally calls Microservice 3. So 9091 has embedded URL for 9092, 9092 will have embedded URL. To call this URL, you always need a local host, you always need a URL and port. So you will be hard coding the URL and port number for microservice 3 in 2 and 2 in 1. What if I am making some changes in microservice 2 and I'm going to change the port to 9094 from 9092? Now my microservice 1 has to be redeployed because it has hard coded the address for microservice 2, which is very bad practice, because if you're changing anything in one microservice, it should be independent of first microservice. And that is the basic reason why we have segregated the complete standalone application into different microservices, so that they should not depend upon each other and they should be easily independently deployable. But since we have hard-coded the location of microservice 2 into microservice 1, this is very tight coupled. So whenever microservice 2 is moved to some another domain, microservice 1 has to be redeployed to be able to search microservice 2 dynamically. Now consider an situation where you are deploying this on cloud. The cloud is the one who is going to deploy your applications and give the dynamic IP address to all the microservices you have in picture. So anytime your instance dies, another instance comes up, it will be given a dynamic IP address, new one. And then will you deploy each time all the microservices? So when this complete 3 set of microservices goes into cloud, handling the location of these microservices becomes a nightmare. And hence comes the service discovery. So what the service discovery says that I'm a registry. So if you have seen a phone book directory, I know that I need to call Mr. XYZ. So I just want to go to the directory, search the XYZ person name and phone number will be there. I don't have to remember the phone number. Similarly is the Eureka or the service discovery. They say that you come to me with the name of the microservice you need and I will give you the URL for it. You don't have to hard code anything. So even if microservice 2 changes its location, microservice 1 do not need to be redeployed with the new location, be it in local, be it in on-premise or be it on cloud, hybrid or public one. Doesn't matter. Eureka will be the one who will be giving you the exact address and who is going to maintain the address of each of the microservices, and each of the microservice task is to update its location to Eureka so that other microservices can discover them properly. And that is the service discovery. The Eureka is the service discovery. So service discovery is a process by which microservices locate each other dynamically at runtime instead of relying on static URL configurations in the properties file or in the code. So multiple Eurekas servers. Now you understand that yes, we need Eurekas or the service discoveries. The next second question for sure interview will ask you that, okay, you have 3 microservices, you have 1 Eureka. And you ask the Eureka, give me the location of microservice 2. It gives you the location, you hit microservice 2. Microservice goes to Eureka. Microservice 2 gets the location for microservice 3, hits the microservice 3. What if my Eureka is down? Isn't this a single point of failure? What if this is down? Then what will happen? Your interactions with Eureka is gone because Eureka is no more available to take any of the queries for service discovery. In that case, you also always should have multiple Eurekas in place. So multiple servers offer a high availability and fault tolerance. They usually work in cluster to provide you the redundancy, ensuring that even if one Eureka server goes down, another Eureka servers or the service registries continues to handle your service discovery request. So microservice 1 and microservice 2 are coming for service request. If this one Eureka is down, you always have another Eureka who is perfectly fine, and now all these requests will actually be directed from this Eureka to this Eureka. So even if this Eureka is down, the second Eureka is up and running for you, and you can always ask for the microservice to address to the second Eureka who is in sync replica for Eureka leader. So that is why firstly, this is why the service discovery is important, and secondly, that is the reason you should always have the multiple replicas for your service registry, so that you don't have to have a single point of failures even if one single Eureka died. The second important question for microservices: what is circuit breaker design pattern and why is it important? So what happens if microservice 1 is going to call a microservice 2, but microservice is down? If this microservice is now down, I'm going to mark it as red. All the things I'm going to mark it as red is going to be denoting that it is down. So if microservice 2 is down, it is not going to respond to microservice 1. In that case, what will happen? If there is no response to microservice 1, who is going to respond to my client? So here there must be a client who is going to wait for the proper response. What is microservice 1 going to respond if microservice 2 is down? In that case, spinner is going to continuously move round and round and keep our clients waiting, and there might be a chance microservice 2 won't come up again ever. Then the client will be an infinite waiting loop, which is a very bad user experience. So to prevent such situations of microservice failures, we have something called a circuit breaker design pattern. So circuit breaker design pattern is used to detect the failures and encapsulate the logic of preventing the failures from constantly recurring during the maintenance or system failures. It acts as a proxy that monitors the failures and opens the circuit if failure is reached, and prevents further call to the failing service until it recovers. So how do we implement it? In the microservice 1, we implement a circuit breaker design pattern logic. We say that try 3 times. If microservice 2 doesn't respond with the proper response, then put a logic that, oh, the microservice 2 is down, please try again later. And that response is sent back to the client. In this way, client is not in a dilemma, like what is happening, why is my request taking so long? It will clearly understand that something is wrong with the backend and some of the microservices not responding, and that is why I have to come back again with my request. So that is how the circuit breaker works. How can you imagine a circuit breaker design pattern? So the circuit breaker design pattern is just like a safety valve. It monitors the service. If it is repetitively failing, then the circuit breaker opens up the connection so that the entire system is not crashed or is down. So it is always better to remove the part which is crashing again and again rather than hold the application down because of one small microservices. Now, how do you handle transactions across multiple microservices? So handling transactions against multiple microservices can be very challenging. I'll give you an example. So suppose you have a restaurant microservice, you have a food catalog microservice, and you have an order microservice, and this is the food delivery application's small prototype. Now, you have to take an order as a restaurant. You have to fetch the food catalog or the menu you have. And once the person selects the proper food items it needs, you have to update the order microservice and you have to deliver it to the consumer. Now the transaction goes is that it orders the food, it searches for the food catalog and places an order. It's not in a single microservice, right? So if it is not able to pay to the payment microservice, then your order has to be failed. In this situation, you have to have a proper distributed transaction management that if the payment is not done, order has to be cancelled and restaurant has to be notified that there is no order yet because the payment has failed from the user. So this is a very big challenge to manage your transaction across multiple microservices. So this involves breaking down a transaction into smaller transactions that are managed by individual service. So basically we use Saga design pattern for such distributed transactions. What does Saga do is they create proper events. So event 1 will be handling the restaurant microservices. The event 2 will be here in the Microsoft food catalog microservices returning you the menu. The third event will be taking the order. As soon as you go to the payment microservice and you say the payment has failed, the compensatory event is passed to order to cancel the order in the order microservice. The compensatory event is then passed to food catalog and restaurant microservice to cancel any of the changes that have been done by the user on that particular microservice. That is, it might have choose some dishes. It might have been removed from their inventory, which they have to take it back because the order was not successful, and they can still take another user's order for that particular dish. So that is how we handle the Saga design pattern for distributed transaction management. So there are two types of Saga implementation, choreography and orchestrator, where the choreography design pattern is done through the events. Like restaurant is going to pass an event to food catalog, food is going to pass an event to microservice, microservice is going to pass an event to payment, and so on. But when the number of microservices increases, this becomes very difficult because there are a lot of microservices and there are a lot of messaging in the messaging queue, and that becomes very difficult to understand which event is for which microservice. So it's better to use, if there is a large number of microservices, it is better to use an orchestration based Saga design pattern where there is a central coordinator or an orchestrator who is going to order each and every microservice, whether they have to roll back or they have to proceed with the commit. Also, we have covered the Saga design pattern in very depth with all these two implementations. You can go into the channel and have a look. If you don't find one, just ask us. We will give you the link for that also. Now, from the microservice interview perspective, very important question. How does microservices communicate in your project? So your project might have tens and hundreds of microservices. The question now lies is, these microservices cannot work independently without getting the data from each other. So they have to communicate for sure with each other. So how do they communicate? So basically there are two ways to communicate with each other, synchronous way and asynchronous way. Synchronous way is very straightforward, but it leads to very tight coupling and latency issue, and that can be done through REST APIs or gRPC. While the asynchronous communication is done through message brokers like Kafka, RabbitMQ, ActiveMQ, but these are put and forget type of communications where you drop your message and forget that you have sent it. They will, whenever they are up and running, they will pull your message from the queue and will process it for the further communication. These are basically asynchronous communications. These makes your services very much decoupled. So if a restaurant microservice has to take food catalog, without it cannot move further, then it has to be the REST API, the synchronous way. But if you had proceeding with the order and you need to send an email to the consumer, you can process another user's request also, and by the time keep your email sending in the email notification microservices and go on and handle another users. So that can be, sending an email can be a good use case for asynchronous communication. So talking about the asynchronous communications, we have Kafka in place. Kafka is one of the very much used distributed streaming platform and also is used for asynchronous communication between multiple microservices. Now, we are going to cover few of the important questions for Kafka. That is, can you explain the architecture of Kafka? So Kafka is the one who is very much in hype today in the market. And it is because of its robust architecture with multiple components and their capabilities to handle loads of data, and you can use it for streaming purpose also, and not just for asynchronous communications. So basic components of Kafka are producers, consumer. Producer is the one who is going to produce to your Kafka topic. So you have Kafka here. For this Kafka, you would need a producer who is going to produce. You would need a consumer here who is going to consume the messages from Kafka. Producer is going to put some messages onto the queue, and consumer is going to consume from that Kafka topic. So producer is the one who is going to publish the message to the Kafka topic. Consumer is the one who is going to subscribe to the topic and consume the message. Remember, just like in another queues, Kafka will not remove your message after consumption. It is going to have a retention policy till the time you have the data in your topic. The next is topic. Topic is the one which is categorized to which messages are produced by producers. Brokers are the one who are the servers, Kafka servers, who are going to store and manage the messages. The partitions, so basically for the server side, we have a broker. Broker has topics, topics has partitions. And this is how your hierarchy goes. Kafka servers are the brokers. These servers have the topics. Onto the topic, producer writes and consumer consumes. But the partitions are the basic level where your actual data is placed. So topics are divided into partitions which are distributed across brokers for fault tolerance. So if you want to dive deeper into it, you can assume that in a good robust application, you should never have one broker. You should always have multiple brokers in the Kafka, because you have to have the fault tolerance. If that particular broker dies, every data you have, that is producer is produced and consumer could not have consumed, is lost. That is why you should always have multiple brokers, and you should always have all the brokers in sync with the leader broker. So there is always a concept of leader broker and in sync replicas who are going to replicate the data, so that even if the leader dies, the another topics or the brokers who are in sync replicas of the leader is capable enough to become the next leader. So that is why in a good Kafka implemented application, you always have multiple brokers. Brokers have topics, topics have partitions, and these partitions actually contains the data, and data is replicated in these partitions across multiple brokers. Now, if the broker leader dies, then who is going to elect the next in-sync replica and make them as a broker? The task of that is usually done by Zookeeper. So Zookeeper is the one who manages and maintains and coordinates between multiple Kafka brokers and maintains the information of leader, and you do the next leader election in case the leader dies. So Zookeeper is the one who manages all these things. So that was a very basic and very high level architecture of Kafka. We won't get enough time to explain end-to-end complete architecture for 15 minutes in an interview. If you want to know more about this, we have a video on this also on the channel. Now, how did you implement Kafka in your project? So in our project, Kafka was implemented for both the things, real-time data streaming and for handling the asynchronous communication between multiple microservices. Here, our producer used to produce data to topic. The partitions are there for scalability. We have multiple brokers to maintain the in-sync replicas for this leader, so that even if the leader dies, we do not lose the data at production, and that is why we have proper fault tolerance with the Kafka brokers also. We have consumers who are going to subscribe and get the data. Either they can have it as a log or they can have it as a microservices where we have to send emails asynchronously to our clients. Also, we have used Kafka Stream APIs for processing and transforming the data. And the important thing is we have used Zookeeper, who is going to manage the brokers we have in the system. For now, we have a Zookeeper in place, but as we are going to upgrade our Kafka to a higher level, that is 2.8 and more, we are going to remove the Zookeeper dependency, because in the coming forward versions of Kafka, you will not have to run the Zookeeper whenever you run the Kafka, because it will be an integrated part of Kafka itself known as Kraft. So whenever we run in the project, we have to right now currently run two things. We need to run the Zookeeper and then we have to run the Kafka library, so that we have proper brokers in place. so that we can send the data to and from the Kafka topics and partitions. So that is how we have implemented Kafka in a project. We can also use Docker to run our Kafka service. Again, what is Zookeeper in Kafka, and can Kafka be used without Zookeeper? So Zookeeper, as discussed already, is used in Kafka for managing the brokers, maintaining the metadata about topics and partitions, handling the leader elections in case the leader dies, what will happen, who to choose the next, who is already an in-sync replica and who is not, and out of those replicas who are actually properly up to date with the leader, from them whom to become the leader, is all these decisions are taken by the Zookeeper. After 2.8.0 introduction, there is no need for running Zookeeper explicitly, because now they have integrated the Zookeeper into the Kafka library itself, known as Kraft. Again, a very important topic, what is in-sync replica? So it looks like a very difficult term, but it's very simple. In-sync replicas are just the set of replicas that are fully caught up with the leader's data. So suppose my producer has produced 5 messages. Now I have 3 brokers who are capable enough to handle your data. But out of those 3 replicas, only 2 of them are in sync with the leader. That is, only 2 of the brokers have total of 5 messages. Rest, another broker has only 1 message and have already lost the 4 messages. So total of in-sync replica only 2, because only 2 are properly updated with the leader's data. So in-sync replicas are those replicas who are completely fully caught up with the leader's latest data, so that if the leader dies, it knows that the consumer can consume from this another replica who has the complete end-to-end data which the faulty leader has. So these replicas are essential for ensuring the data durability and consistency, so that if the leader fails, one of the in-sync replica can become a new leader, and this selection is done by Zookeeper for us right now. Later on, it will be integrated as a part of Kafka only. Now, 2 important concepts still remaining. What is a consumer lag, and how do you mark an offset, and why do you mark an offset? So consumer lag is a very important concept when you work with Kafka. Consumer lag is a difference between the latest offset of the partition and the offset of the consumer's last processed message. Too much of theory. Let's understand it in a simple way. There might be a difference with the speed with which consumer consumes and producer produces. So if producer is dumping your Kafka topic with 1000 messages, but consumer is not very fast to read all those 1000 messages quickly, there comes the lag. So that is a consumer lag. With the speed with which consumer consumes and producer produces. So whenever the consumer is reading, it should mark the offset on the broker that this much I have read, so that even if the Kafka in near future dies, it knows that even if this much cannot be retrieved, another this chunk has to be retrieved because consumer has not read it, even the producer has produced it. So marking an offset immediately after reading the message by the consumer ensures that message is acknowledged and committed quickly. However, it can lead to message loss if consumer fails before processing the message. So there can be a case that consumer was about to mark the offset, but it died in between. So the message will be lost because consumer didn't mark it and producer has produced it. But in the good situation, or in the best case scenario, if everybody is up and running, marking an offset is very important because it tells the Zookeeper and the broker that the producer has produced this much, but the consumer has only read till this amount because the offset is marked only till this number of partitions. So typically offsets are committed after the message is processed properly by the consumer. So that is why whenever you read something from the Kafka, it's a very good practice that you acknowledge and mark the offset that yes, I have read this much. Now, if the consumer dies and when it comes up again, it knows to where to read from again. It will not start from 0. Otherwise, it will be getting duplicate message records, which is very bad in terms of logs. So if you have logs and you know that some error is coming, how will you feel if you get the same error twice or thrice? Won't it be very irritating? That I understand that you are getting 401, but getting the same message 10 times or 15 times in your log is very irritating. And to prevent that, there comes the marking offset feature. That as soon as you get, okay, I got 401 exception, mark it, let's go ahead and let's see where another exceptions are coming in the picture. So that is why Kafka's offset marking is very important. There are many deep and complex questions about the Kafka, like consumer groups, how many consumer groups should read from a partition, what is offset marking, how are partitions divided, how many consumers read from how many offsets and partitions. Very complex topics are still there. If you want to know about more of them, just let us know in the comment section. We will create a very separate video for Kafka interview questions for you. Let's quickly move ahead. We have many more topics to be covered. Let's quickly move to the REST APIs. So when we were discussing about microservices, we have talked about the way how microservices communicate with each other. There was a synchronous way and an asynchronous way. We have covered an asynchronous way with Kafka, and similarly we have ActiveMQs and RabbitMQs. They work on the same concept of queues and topics, where you leave your data on the brokers and topics and queues, and whenever your consumer is up and running, it will pull the data, or either the broker will push the data based upon which implementation you have for asynchronous communication, and will process the data asynchronously without hampering your another task in the application. But when it comes to the synchronous communication, always go for REST APIs or gRPC, because these are the best way to communicate communicate synchronously between multiple microservices. So what is a synchronous communication? A synchronous communication is where one microservices calls another microservice and waits until it gets the response back, and will not take any other work for that particular thread to handle another user request. So this is a blocking communication where one microservice waits for another microservice's response. Such microservice communication is called as synchronous communication, and it is usually implemented with either with the gRPCs or RESTful APIs. So we have HTTP or HTTPS protocols for such kinds of communications, and we have Spring tools like REST template, which is for normal blocking programming paradigm, or we have web client, which is used for reactive web applications, where we have to use a reactive code library for making API calls. Next is, there is a very important scenario based question that can be asked by an interviewer, that you have created your REST endpoints, you have a proper CRUD functionality implemented, you have 10-15 endpoints created as a part of your end-to-end implementation for an enhancement. Now you have a client or another team who wants to use this particular endpoint you have created. So how will you tell them about all these 15 endpoints? I am going to go to them and say that I have a get call, I have 2 put calls, I have 3 post calls, I have 1 delete call also for you. But while deleting, you can also send ID, or you can also send list of IDs. Are you going to go and tell each and every of these things to them openly, verbally? Which is a very bad idea, which you should never do. And hence we have Swagger in place. So Swagger is basically an open API documentation, which when annotated our REST APIs with that annotation generates the API documentation, which can be easily accessed via dashboard also. We have a proper Swagger dashboard, and you can give that dashboard URL to your clients or to the another teams who want to use your endpoints. And that documentation involves complete details about your endpoint. Even you can give examples there, like when you hit this particular request with this particular body, you will get this kind of response. If you send it without any headers, you will get unauthorized exceptions also. So all these things you can add in your Swagger contract and share that Swagger contract with the team or the client who actually wants to access your endpoints and serve some capability to the client. That usually completes our REST API implementations. Also, these are very commonly asked questions. If you have questions that have been asked in an interview which is above this and more complicated, just let us know in the comment section. We will cover all those questions in the upcoming videos for you. We still have many more questions to left, so let's quickly go ahead and let's see how you have implemented security in your project end to end. If you have having 8+ years of experience, this question is bound to happen. There is no going away with the Spring security or security feature, because whenever you implement an application, security is the first and the foremost thing that you have to have for a production ready application. Otherwise, hackers and the users there will take an unprivileged actions on your application. So whenever it comes to security, there are two important things: authentication and authorization. So in most of the Spring Boot application, authentications are always done with auth2 and JWT tokens, and authorizations we have role-based access control for ensuring that you have proper permissions for the various endpoints to access. Authentication is telling them who you are. Authorization is telling them what all you can do in the system. So suppose I have GET APIs. Anybody with any role can see what data we have in the database. That is open GET endpoint. But to create a data or to amend or put or update any data, you always have to have a proper access. That is ensuring that you have proper access to update the data in database. Otherwise, anybody will come and update your data. So that is authorization part. So when it comes to an Angular application with Spring Boot as a backend, you have to have an authorization server, that is Okta for you. So that is going to give you the proper token. Now let's quickly create an AI diagram for this. I have steps with me. I'm going to paste the steps and create a proper sequence diagram right now. So I have my AI diagram with me. Let's understand the flow and then let's come back to this diagram that AI has created for us. So first thing we have to do is to set up an Okta. When it comes to an Okta implementation for your front end and back end, you have four main actors. You have a user who is trying to access your application. You have a front end, which is the UI for you. You have a backend, which is having all the data secured, and there is an Okta, which is an authorization server for you. So first thing you have to do is on the Okta, create your account. By signing up as a free developer, you can create an account freely on this. Then since you have an Angular to be implemented as a single page application, you have to create a single page application in Okta, and then Okta is going to give you two important things: the client ID and issuer URL. Remember to copy and keep it safe with you, because these client IDs and issuer URLs will not only go in your Angular application, but will also go in your Spring Boot application. So make sure to note these important details, which will be used for both the applications. Now, as soon as you have created your account on Okta, you have created your application and registered it there, you got your client ID specific to your application. Now you have saved it all. The next thing you have to do is to configure your front end. So you have your front end up and ready. The last thing is to implement the security. So at this point, you have to install your Okta dependencies so that you can connect with Okta and get the tokens, which is responsible for access the secured backend APIs. So what happens in security is, you are the user, you log into your Angular application. As soon as you log in, you are redirected to Okta to make sure that you are authenticated and authorized. When you have properly provided your passwords and IDs, it checks whether you have a proper access. If it is going to give you the token. With this token, you go from Angular application to Spring Boot application. This Spring Boot application or the backend has proper APIs which are secured. Only if you have a proper correct token, the JWT token, then only you can get a response from the Spring Boot application, else you will get an access denied or 401 exception. That is the basic logic of authentication and authorization for security implementation in a complete full stack application. So the first thing you did is you went to Okta, created your account, created your application, got your client IDs so that you can get your tokens. You went into Angular, you have installed proper Okta dependencies into your application. You have set up those client ID and secrets in your constants. You have converted all your routes and guards to handle these particular authentications and authorizations. and you have added your login button. So the first and foremost thing, which is very important to have a login button, because as soon as you click on login, the task of this Okta is it will redirect it to its own Okta page. The Okta page actually looks something like this, where you provide a username password, and the task of Okta is to authenticate and authorize you. As soon as it checks the authentication, now you go into your backend, you install Spring Security Starter dependency, you install Auth2 because that's the basic underlying protocol for your authentication and authorization part. The Okta Spring Boot Starter is going to have an integration with Okta endpoints. When you have these three dependencies added in your Spring Boot application, the next thing we do is we set up a web security configuration. This is something which is before Spring Boot 3.0. The changes have been done after Spring Boot security, how Spring Boot security is implemented after that. If you want to know about it, let me know in the comment section. I'll create another video. For this Spring security implementation with Okta, and complete end-to-end project is already created and is on the channel. So you create your Spring security configuration where you authorize your request and says that any API which is having the path like API which is public, you have to permit all. Rest all you have to authorize, authenticate and use a JWT for authentication and for authorization part. The next thing you do is you have your client IDs which is already in the constants of your Angular application. Also add these in your properties file, because these client IDs, your domain and everything is important for getting and fetching the token from the Okta, and in the backend it is important for validating your token. Now I have a controller, so I have to make sure that my APIs are secured. So there are two ways. Either you use annotation like pre-authorized annotations for your authorization part, or you can have proper public and protected such kind of endpoints. So /public, /API, /public are those which are properly permitted, and rest all are protected. So /API, /protected are not going to be permitted one. You have to have a proper token to access the protected endpoint here. Now you have your coding done for your front end and back end. The last thing is to integrate them. So you have the HTTP client in your front end. You go to Okta, get the access token, append it with the bearer token authorization header, and then you call the protected APIs, and you will be able to get the data properly. So after the successful login, the Okta provides you the token. That token you use to access any backend APIs from your front-end APIs. The task of backend API is to authorize you, check whether you have proper valid token, and ensures that you are authenticated and authorized for it, and then it will give you response only then. So the quick summary, you set up your Okta account, you do the Angular configurations, you provide proper Spring Boot configurations for backend to validate the JWT token that is issued by Okta to your front end. And then you integrate your front end and backend to use that access token to hit the backend APIs. Now let's come to the flow here quickly. You are a user. You are going to log it to the Angular application. Whenever you click on login button, you are redirected to Okta. It checks for authentications and authorizations. And as soon as you provide the proper credentials, it will verify the credential and give you the token. When you have the token, you pass that token to the backend and also simultaneously store it in your local cache or the session. When you are giving the proper access token, it will validate the token. How is Spring Boot going to validate the token? Because you have proper configuration done in your properties file. That is why it is able to validate that token with your Okta. So also in the local validation, what it does is it checks the token validation. It checks the signature. So JWT token comes with a XYZ format, where Z is the signature. So it checks the signature, it checks the token expiry, it verifies the token issuer, does everything, and when everything is successful, it returns you the protected data and gives you the proper data. If it finds that any of these things are tampered, which a hacker can be sitting in between and might have modified your JWT token, so that rather than a legitimate client can get the data, hacker can get the data. To protect that scenario, it will validate the signature. If signature doesn't matches properly, it will return an error message saying that this token is invalid. You have tampered the JWT token. You are not authorized to see the protected data, and give an error to the hacker or the unauthorized user here. So that is the end-to-end flow how the authentication and authorization is done using Okta as a third-party tool between your full-stack application with Angular and Spring Boot. Let's quickly move to the ORM framework that you might have used. So usually we use Hibernate as the ORM framework, that is object relational mapping between your Java code and your tables that you have in SQL or NoSQL. For SQL database, we have used Hibernate, and for NoSQL DB connections, we use MongoDB. Now, the next question here fire you is what have you used, SQL or NoSQL, and why? So we usually in most of the cases or the good applications, we have both. We have SQL databases for transactional data because there might be some payments happening. There might be some very complicated things happening where asset properties are very much important and queries might be very complex. In such situations, SQL database is very important. So for example, I have an order microservice, I have a payment microservice. So between them, you should always maintain a SQL database because their consistency and atomicity is very important. When it comes to simple order management, then you can have anything like NoSQL DB where your data is unstructured because my products, my dishes, my items, my everything might change a lot, right? So to handle large volume of unstructured data, you have NoSQL DBs. So you might say that we have used both. You have used SQL where asset property is very important, and you have used NoSQL where the complicated queries are and joins are giving you trouble. There you have used the NoSQL databases where you have very high scalability and performance because you quickly get the data in just one single way, because as soon as you get the document, you get the whole object. You don't have to put any join, you don't have to have any foreign key, any constraint is not required, and hence for the good performance you have NoSQL in place for such situations where asset property takes the setback. Coming to a very important topic that you must know at 8 plus of its experience is Docker. So let's quickly cover very commonly asked questions for Docker. So why have you used Docker in your application? And what is Docker? Docker is a containerization tool. What does that mean? So I have an application that is running on my local. I push the code to Git. My colleague or teammate takes the pull. That functionality is not working on his machine. It says that, hey man, your functionality is not working. And I say, but it works on my machine. So this problem of application working perfectly fine in one machine and not in another causes a lot of trouble to us. And in such situation, what we should always do is we should package the complete application with its environment in a container and deploy the whole container to an environment for others to test, so that the application working with the same dependency, same environment in my machine is also on the development or production environment. And in that case, you will not face a situation that, hey man, it works on my machine, I don't know why it is not working for you. So Docker is the one who containerize not just your application, your environment, your libraries, your dependencies into one single container and deploy it across your dev environment, your test environment, and your production environment. So it simplifies your dependency management. It enhances your scalability. Isolation of application is easier to manage and deploy your microservices. So that is why Docker is very important for containerization and to make sure that it works on all the machines. Now, what are very common Docker commands you might have used? Now, it can be situational based. You might have used these commands and you might not have, because if you have a proper Docker file in place, you might not have to do all these things. But to run it locally and check it, you might have run the Docker build command. So what does Docker do? It reads the Docker file, it creates an image, then it runs a container, and your application is up and running. So Docker build is the one who is responsible for building the image from the Docker file. Then when you have the image up in the Docker hub, how to run that particular image? You can run the image and create a container with a Docker run command. So it runs a container from the image. So it creates the container and make your application up and running. With Docker run, your application is live now. Now, if I want to list all my running containers, I can do docker ps. If I want to stop a particular container, I can do docker stop. I want to remove a container, I can do docker rm. And remove an image, I can do docker rmi. These are very commonly and frequently used commands. Now, a very important question that for sure you should understand when you have a Docker file in your project. So first, explain the Docker file. A Docker file usually starts with from an OpenJDK library, which is the parent image. So this line specifies the base image that the Docker container will use. So this is the base image. So I want to use OpenJDK as my base image. Second is, it is basically being deployed somewhere, right? It's some environment. So it is going to change the working directory to /app. So this sets the working directory in the container, inside the Docker container. Because it's an image, there will be some directory where my data has to be placed so that it can run from that particular directory. So in this directory, usually I'm going to put my jar and I'm going to run from this directory and my application will be up after that. So I have created and changed my working directory to /app in the Docker container. Now I have to copy all my data from my target folder, the jar that I have created from my Spring Boot application. I have to copy it to my working directory's app folder. So copy the jar which is in my target folder, which is created by Maven Clean Update, as it is going to have the latest jar. I'm going to copy it into my app working folder. So this copies the Spring Boot applications jar from the target folder on your local machine to the app directory inside the Docker container. Now you have your application copied into the Docker container. This exposes a port 8080 on the Docker container, which is typically the port on which your Spring Boot application that you have copied from your local machine to your Docker container will run upon. So you're going to expose this port, and when this port is exposed, you can access your application at this port number on the Docker container. Now everything is done. We have to run our application now, right? So what is the Java command for running your application? That is java -jar, your jar name. So this command specifies a command to run the Spring Boot application when the container starts. So the entry point is that run the command java -jar and your working directory / your own application.jar. As soon as this particular command runs, your application will be live on this particular port number in this particular working directory. So that is how you read the complete Docker file. Next, we have Kubernetes, which is a very important topic again, because nowadays with hundreds of microservices in place, you cannot live without containerization technique, and you cannot work with an orchestrator who can orchestrate all those hundreds of containers on cloud. So Kubernetes is the orchestrator who manages all these containers. So when your container dies, so you have 100 applications, okay? If one of your microservices die, are you going to continuously make sure that your application is up and running, all the 100 of them? You cannot do that. So what you do is you use Kubernetes. You have your containers created with Docker. So you have 100 microservices, you have 100 containers. These containers are wrapped into pods, which are the working unit for Kubernetes. These pods are up and running, then your application is up and running. If one of the pod crashes, it is the task of Kubernetes to restart your pod so that your application is not affected. So orchestrator tool for your containers is Kubernetes. Now, what all commands you might have used while working with Kubernetes? So yes, Kubernetes do reduce your task of continuously monitoring your containers on the production. What it does is, it creates pods, and those pods are the smallest workable unit in your application. But many a times your pods might crash. Many a times your deployment might fail. Many of the times your services might not be working. In that case, you have to know some commands to see what is going wrong. So these are some very common commands you might come across. kubectl get pods. It will list all the pods in the namespace. And what is a pod? Pod is nothing but a container in which your application is running. So I have 10 microservices, I will have 10 pods minimum, which will be capable enough to run one container inside it. Usually the backend people do such follow that one pod should have one container. There might be a case that one pod can have multiple containers, but that is a very bad programming paradigm and practice. Next is when you get all the pods, you can need a particular specific pod only. Then you can say kubectl describe the pod and give the pod name. Because you have all the list of pod in the previous command, you can give the pod name easily here. Now my particular pod is crashing again and it's in crashback loop. I want to fetch the log for that particular pod. Why is that particular pod not working? There might be a case that I might have forgot to push one property file, one property in the property file. In that case, I need to find because of which property my pod is getting crashed. To fetch the log for that particular pod, I have kubectl logs for that particular pod name. Then you want to apply a configuration, then you have kubectl apply -f and those configurations will be applied to that particular pod. If I want to delete a pod, you can do kubectl delete pod and give the pod name. So these were very commonly and frequently used commands. But a very important question is, how will you analyze logs of a pod? I understand you can do kubectl logs, but it will be difficult to see all the logs in command prompt or the terminal. So you have a proper log management system where you have a centralized logging solutions like ELK, Fluentd with Elasticsearch and Kibana, where logs are collected, aggregated and visualized to monitor and troubleshoot. How would you troubleshoot and diagnose issues like pod crash? Remember, this is a very common problem. Whenever your application is not able to start properly, your pods might crash again and again. In that case, you need to have proper troubleshooting and diagnosis with you. You can have a failed deployments, you can have a network connectivity problem in the Kubernetes cluster. How would you solve these issues? So if you're working with Kubernetes, for sure once in a lifetime you will see the pod crash issue, for sure. How will you troubleshoot? The first thing is check the logs. So if the pod crash, the first thing you have to do is kubectl logs for that particular pod name and you will be able to identify the error. If you are still not able to do that, you can describe the pod with the pod name to inspect events and resource issues if there is some hardware or a resource or networking issues. There can be a case that a complete deployment might fail. Then you can get the logs for that using the Kubernetes or kubectl get deployments and describe the deployment similar to how you describe the pod. A kubectl describe the deployment and deployment. Here you can look for issues in configurations, resources or image pool errors. So there might be a case that you might have created an image but image is not pushed to your remote repository like Docker Hub. In that case, you will not be able to get that issue in the pod crash issue, but you have to check the complete deployment because it's not the pod issue, it's the external issue. That is, your image is not fetchable. There you have to check the deployment status. Next, you have connectivity problems. There you have to use the exec command where you have to access the pod shell and test the network connectivity using the pin on the curl command. Here you can check the network and see whether your pod is reachable by pinging it or by using a curl command to reach through that. Now a very basic question. Explain the difference between pod and container. Container is a term for Docker. Pod is a term for Kubernetes. So pod is the smallest deployable unit in Kubernetes, representing a single instance of a running process in a cluster. So if I have a Spring Boot application, usually that Spring Boot application will be containerized by Docker and will be deployed in a particular pod. That pod is a simple running process or a running application. A pod can contain one or more containers, but that is a bad programming habit. Usually your one pod should have one container. A container within a pod can communicate with each other using the local host and using the shared volume spaces. So that was a basic difference between pod and container. These are the two things of two different technologies. Container is for Docker and pod is for Kubernetes. A very important question when it comes to 8+ years experience. You should know how your application is flowing through a CI/CD pipeline. So let's first understand what is CI, what is CD, what is difference between them, and let's see what is the steps you have used in your project. Usually most of the projects have the same steps followed. Here and there 1-2%. Otherwise most of the projects follows the same steps. So if you are able to make them understand this, they would know that yes, you know how your CI/CD is working in your project. So CI is continuous integration, CD is continuous deployment. Continuous integration is automatically building and testing the code changes as they are committed to version control system. Too much of theory, let's understand it in simple terms. Continuous integration is, so suppose I have 5 team members. I am going to work on one particular functionality on the same application. My friend is going to work on another functionality on the same application. At the end, by the end of my sprint, I will demonstrate mine, he will demonstrate his, but by the end, the complete functionality will go to the client. So what is required here is a central repository where the basic code is written. I'm going to push my code to that particular repository. He's also going to put his code to that repository. At the end, we should make sure that the application is still up and running. The existing code is not broken. All the existing test cases are running. Our new test cases are also running. Our integration is still there. All these cases, once checked, then it should be deployed to a production environment, testing environment, and the pre-prod environment. So that our testers can validate it. Our pre-prod environment, when it is stable, we can make it to production environment. So this is the basic life of a code it has to go through before it is merged to master. Also, there is a very important thing where there comes the PR reviews once you have completely built your code. So continuous integration is integrating your code that you have developed in your local into a remote repository, right? Git. Continuous deployment or delivery is deploying your code changes to an environment, be it development environment, be it test environment, be it QA environment, be it pre-prod environment or prod environment. So that is CI and CD. Continuous integration is integrating your local code to GitHub. Continuous deployment is deploying your new code from your local to a particular environment. So what are the common steps used in CI/CD? So let's go to the canvas and let's quickly see how the code actually flows in CI/CD pipeline. So I have multiple microservices, okay? And every code is in my local right now, in my desktop, in my system. I am going to push it to my GitHub repository. From there, my CI starts coming into picture. That is the Jenkins pipeline. This continuous integration makes sure by the end of this, you have your code merged to master and prepared for deployment. What it does is, it creates a webhook to your GitHub repository. It clones the repository. It runs the Maven build in the Jenkins folder. When it sees, okay, Maven build is fine, your test cases are fine, the basic steps is basically Maven build, JUnit test cases are fine, your system integrations or BDDs are working fine, it will create a jar or the war based on your pom.xml, then it will create a merge request to master. Your local branch will be then, after approval, will be merged to master. Once done, it is merged to master. It will create a Docker image and that image will be pushed to a Docker hub or the remote repository where your images are pushed. And it will update in the manifest repo that you have a new image present in the desktop. Then comes the CD part. What the CD part do is, it continuously polls the manifest repository. As soon as it finds any change that a new image is uploaded, it will deploy the latest image as a container in your Kubernetes pod. That is CD part. The CD part is continuous deployment. It will keep on polling your manifest repository. Is there any new image? Is there any new image? Is there any change in the application? If yes, I'm going to quickly deploy this to the environment so that it will be ready for testing by our QAs. It will be ready for pre-prod and then we can, once done, merge to master, deploy to prod. And when everything is done and deployed to production and other environments, you can monitor and have the proper alerting system in place. So that's the CI/CD steps. The code is committed by developer from local to the version control system like Git. The CI tools like Jenkins automatically tickles the bill. It will do the Maven clean. It will run the JUnit. It will run the system integration test, creates the package, the war in the jar. It will execute all the validations on the code, package it and create a container out of it. It will upload the image Then comes the part of, after PR approvals and merge, comes the part of deployment, where it will see, okay, I have a new image created in the manifest repository. Let's approval and let's deploy it to the environment. And then post deployment, let's monitor and alert that the application is running perfectly fine. So that's the CI/CD common steps which each and every project follows, be it any project. The last thing we have to cover is cloud. Which cloud platform have you used and what services you have used? So this is a very common question which you will for sure will be asked. So usually most of the projects use AWS, Amazon Web Services extensively. Usually the commonly used services are EC2 instances, which are the virtual machines. You use the storage buckets, that is S3. You use RDS, that is for the relational database management. You use MongoDBs. You use Lambdas. Lambda is a serverless computing for running the code without any servers. You use EKS because most of us in the cloud use the pods and the containers. So to manage your pods and containers, you have Kubernetes. That is a container orchestration tool. And for monitoring and logging, you have CloudWatch, which is given by AWS to you. Now I have many more things to cover for 8+ years experience, the alerting, the logging, the Prometheus and Grafana's, how they work with each other. Then we have shredding in databases, difference between Spring Filter and interceptors, how JWT works internally. All these are the very deep questions that can be asked with 8+ years of experience, people. Also, if you want to know more about the CI/CD pipeline, how this is created, how the code goes from one step to another, how CI/CD is implemented, we have a proper course on this on the Udemy. You can navigate to Udemy. Here you can search for AWS Microservice. You can see one of the course by codedecode, which is the bestseller right now. Click on this. Currently it is rated as $7.99 by Udemy. You can get it at very less rate and a discounted price if you go through our coupon code, which is given in the description bar below. Just click on that link and this price will be slashed as a very good discount to you. This particular course is everything, the full stack developer course, from front end to back end to microservices, to how to create JUnits, to how to have the Sonar Cube implemented, how to implement Kubernetes, how to use AWS EKS service, AWS load balancers, MongoDB for Mongo Atlas for your MongoDB's real-time database service, CI/CD. This is what I was talking about. This is also properly implemented with each step in the AWS systems using the EC2 instances also. You have Angular, you have Docker, you have AWS RDS, Jenkins, Argo CDs. Everything is deployed, created, and proper hands-on is there in this particular course. This particular course is available at a very good discount. You can just click on the link and purchase it if you want a complete insight how the basic day-to-day life of a full-stack developer works in an IT environment. So let us know if you need the second part of this video. We will create another one, or else if you want us to move ahead and have some technical architect level interview questions, just to let us know in the comment section. We will create interview preparation for technical architect level also. Thank you.